Hello and welcome back everyone to another YouTube video. This video is the beginning of a new series which will be building projects using Python, and it will not be complicated projects at first. We will begin slowly. It will be very beginner friendly, and if you are coming from CS50 Introduction to Programming with Python, this will be very simple for you because you already have the essential fundamentals uh, to understand what we will be doing. So yeah, and let me know down in the comments if the project is complicated, is hard, or it's too easy. Yeah, so I can decide what will uh, the next project will be. And of course, if you have a project in your mind and you want me to and you want to see me build it, you can mention that in the comments also. So yeah, now let's see what will we be building today. So today we will be building a game called Two Squares Game, and to be noted, the idea of this game is not mine. But the code I built for this game from scratch is totally mine. So yeah, so the idea about this game, it's two player. So two players will take turns and they will choose a square or typically a rectangle. So player one can choose two numbers that are uh, horizontally after each other, like 1 and 2, or vertically, or 1 and 5. So the user or the player can't, for example, choose 1 and 6. So that's not valid square or rectangle, you know. So yeah, that's pretty much the game. And you win when the other player have no place to choose the square. So let's do a quick one. So let's say, for example, player one chose uh, number one and number two, square one, square two. So yeah, as you can see, it's now covered or used. So now it's player's two turn. He can choose 6 and 10, for example, and that's also covered. Let's complete the game and see who will win. Let's do 11 and 15, 9 and 13, and 3 and 4, 12 and 16. Yeah, and I think no, okay, let's do 12 and 16, and the last one will be 7 and 8 because there are no other valid options. So yeah, as you can see, the player one is the last one who will take turn. So now, since there is no squares left for player two to choose, then player one wins. So yeah, that's pretty much the game. It's pretty simple. So yeah, let's get right into it. And first, let's like analyze our game to see what we will begin at. What will the code begin? So I can just uh, build a project without analyzing it or uh, break it down into points. So for this project, for example, uh, the first thing I notice or that I will have in mind to build is the board. So this display here. So that's the first thing I will think about is displaying the board, and then maybe build the mechanics of the game. So how what the user can choose and what he can't choose. And another thing is when a player will win. And also let's run the program again because I want you to see something. So let's say the user chose a wrong pattern. So for example, 1 and 3. So that's not valid. So let's see what the program will do. So yeah, as you can see, we printed a message for the user, which is choose a valid rectangle. And I don't like this colon, so maybe we will remove it when building the project. But as you can see, we are handling uh, user errors. So that's also something to keep in mind. So yeah, what else? Also, changing turns between players and checking if the square is valid. So that's the step I showed you here. And also checking if no squares are left. So that's the game winning condition. If no squares are left, then the last player who made a move or played his turn is the winner. Also, yeah, the very important thing is to also update the board. So when the user types, let's make another turn here. So if the user types 1 and 2, for example, and it's valid, we want to cover the these places in the board. So yeah, we have to think about uh, the project and see where we will begin. So yeah, that's pretty much it. So let's jump right into it. Okay, let's clear the screen. Okay, let's remove the code and start over. And yeah, another thing to be noted is I'm going to build this project um, functional programming, if I may say. It's like uh, making the whole project made of functions. So yeah, I like to do it so because otherwise it will be so messy and the code will not be organized and it will look ugly, believe me. So yeah, the whole project is going to be functions, or most of it. And so yeah, let's start with typing what we want to do. So first the board, and also we can type in the same step to display the board, and yeah, player turns. Okay, and valid squares. Let's call them squares throughout this project. And what else? Yeah, update the display or the board and the game winning condition. I think that's pretty much it. And yeah, let's start with the board and displaying the board. So if you noticed, our board was a two-dimensional array. And yeah, so let's make this first. Let's make a variable called board, and let's store our board here, two-dimensional array. The first row is 1, 2, 3, and 4. The second row is 5, 6, 7, 8, and so on. And the last row. And yeah, that's it. So Actually, I will not use this method to display the board, and I will show you why in a second. So let's print out the board. And the sad news is it's printed in one line, so that's ugly. The game will not look pretty at all, and it will be hard to know what squares to choose from a player perspective. So let's use another method, and for this we'll actually import a library called NumPy, and let's use it as NP. This, by the way, because it will not make us type NumPy each time we use the library, we can just use NP. So the way we will do this is just adding np.array, and I think we need to specify the data type. So this needs to be in parentheses, and at the end I think it's like that, data type. And actually we will not use them as integers because it's not useful. We will use them as strings because these are not actual numbers that we are gonna do any arithmetic things with it, so it's better if you use it as string. So yeah, let's now print the board and see the difference. And the surprise is it's actually two-dimensional and it's looking very good. So yeah, that was the first step, which is displaying the board or making the board. We'll actually not display the board like this. We will put it in a function, but we will also use print. So let's use display board. It will not take any parameters and it will just print the board. So whenever we call this function, the board will be displayed. Maybe let's go. It's better if we call a game. I think it's more convenient to display the game. It doesn't matter really. So yeah, let's move on and let's make our functions for player turns. So let's make the function for the first player turn. And if you recall, because I want you to think uh, about the operations or the code that we write here. So a player turn, what do we need from a player? So let's look here. When it's a player turns, we expect him to give us a combination of numbers, two numbers precisely. So yeah, the first thing comes in mind is taking the the input or the squares from the user. So let's start with this, and the format we are going to expect from the user is a number, comma, space, another number. So yeah, you can change it if you want. You can just make it uh, supported with only a space, so without the comma. So yeah, as you do it whatever or whichever you want. So let's take two inputs from the user. Let's call the squares x and y, and let's take input from the user, and let's type player one turn and a colon, and yeah, and we need to split the input, split, and according to a comma and a space. So if the user, for example, chose 1 comma space 2, uh, this will be removed and 1 will be stored to x and 2 will be stored to y. So that's the first step or the first thing we are going to build when making the player turn. So what else? So yeah, keep thinking. Uh, are we just going to take the input from the user or the squares from the user? Like, are we going to trust them fully? What if they chose 1 and 6? What now? So what comes next if the user chose a wrong combination? What will happen? So for that, let's make an if condition actually, and make sure that these values are valid. Oops. So if is valid, this is a function that we will build after this, but let's assume that it's already built. So if is valid, and we will pass the parameters x and y, and if that's the case, we will do what? So yeah, think about this. If the combination is valid, what will happen after this? So if you recall, after choosing a combination like 1 and 2, the board displayed again, and the 1 and 2 were replaced by a capital X. So what happens if the user's combination is valid? Let's update the board. That's also a function that we will build after in the code. And it will also need two parameters to tell the function what squares to hide. So what if the combination is not valid? What are we going to do? So else, so otherwise, let's actually print a message for the user, and let's tell him to choose a valid rectangle. And let's not add the colon. Uh, as I said before, you will remove it. So yeah, let's keep it like that. And so yeah, we told the user to choose a valid rectangle, but if we leave the code like that, the function will just end here. So like I'm telling the user to choose a valid rectangle, but he will actually not see the option to give input like here. So let's think about it. We need to ask the user again for the input. So are we going to copy this line here and print it here? So this may seem like a good solution for the problem, but what if the user inputs another wrong combination? You will just blindly take the combination and the function will end here. So we need to do the same steps again, the checking if it's valid, updating the board, and else. So what we'll actually do here is simply call the player one function again. So it's as simple as that. Because when this will be called, the whole steps will be uh, done again. So yeah, that's for player 1, and the same is going to be for player 2. Player 2, let's change this, and player 2, player 2. Okay, let's make the message a bit different. Yeah, that's it for the player turns. Now we need to make these functions the valid squares and also updating the board. So let's start with the valid squares. So what can we do to check if a combination is valid? So the only way I think this can be done is to store every single uh, combination that can be chosen by the player. So let's make another variable and let's call it valid values, and here we will store every valid rectangle. So yeah, let's also use np.array, and I will pause because this will take a while, and I will put every combination here, so give me a second. So yeah, here you have it, every combination. So it's 1, 2, 2 and 3, 3 and 4, 5 and 6, and so on, and also uh, vertically 1 and 5, 2 and 6, 3 and 7, and so on. So here it's every possible combination. So that's not actually the function that will check if it's valid. So let's make a new function. Let's call it is valid, and it will take two parameters, and let's call them x and y. But let's first move this above, because I don't like it to be in the middle between every function or between all the functions. So let's move it beside the variable we have here. So yeah, let's separate the variables from the functions. Okay, let's get back to the valid function. And let's also think what will be here, or like what are we going to do in this function. So how are we going to check if a combination is valid? So we have here every valid combination. So what we can do is iterate over every uh, two values here, or every combination here, and see if the combination we have uh, is um, is in the array or in this valid values. So yeah, that's actually the way we're going to do it. So let's make a for loop, but let's actually call this a and b, just to not be confused with the x and y. If you use x and y, it will work just fine. So yeah, let's make a for loop, and it's for I in range the length of the valid values. Okay, because we want to check or iterate over every value in our array. So now it comes to the logic that we're going to use to check. So it will be an if condition, but what are we checking for? So we are going to check if A is a square in a combination in our array. And by the way, it can be, so for example, if the user types 1 and 2, it will work. But also if he types 2 and 1, it's also a valid value. So you want to check if A is either the first square in a combination or the second square in a combination, and B has to be the other value in the same combination. So yeah, that's it. So let's make the conditions, and it will be a bit long because we'll make it in a one line. So if A is equal to valid values and I, or we are going to iterate over each combination. So uh, that's why we are putting I here, because uh, after this we will choose which square. So this is the first square in the ith iteration, or the ith value combination. And let's also see if it's the second value, the second square. So that's actually C++ syntax. So let's just edit this. And let's see. We're not done here, but let's explain what we have done in this if condition. So let's yeah, look at this and let's explain it here. So let's say, for example, the a, or the square that the user, the first square that the user chose is 1, or let's make it 6, for example. So our for loop will start here. The I is equal to 0 at first, so that's the combination that we will have in the first iteration. So here we are checking if the first square in the first valid combination is equals to A, and the same here, but this time we are checking if it's equals to the second square, because I just said that the user can type 1 2 or 2 1. So that's the logic here. And let's also make the same for B. So we can copy this and print it again here. And let's change the A's to B. So yeah, that's the same for A, so nothing new here. Let's just separate the conditions here. And yeah, that's it. And yeah, to keep in mind, we are checking in the same iteration. So what I mean by that, don't worry about like what if he finds or the program finds A in this combination and finds B in another combination. It will not work like that because we are checking in the same iteration. So I is a constant, so uh, we will be in the same combination, or A and B will be checked for only one combination at a time. So yeah, don't worry about that. So yeah, let's stop for a second here again and think, what do we do after confirming that a combination is valid? So if you recall, when a player chooses a combination and it's valid, this will be hidden and it will be an X, and the same goes here. So yeah, I think, oh yeah, this step, let's we will do it in the update function board, but here we actually need to do something very important, which is to remove this valid values from the array, but not just the combination. So for example, if the user chose 1 and 2, we will not just cover this combination. We have to remove every 1 and the 2 from every combination, because if the user chose 1 and 2, the second user can't choose 2 and 6, for example. So if we don't do this step, it will actually make a problem. So yeah, what we need to do here is to remove A and B from every combination, and not just remove the combination itself. So the way to do this is actually going to be using NumPy, and that's actually why I made this array using NumPy, because we will use a method that's like very important, and it's called where. So we need to uh, cover every A and B. I'm trying to be like slow as possible so you don't get confused. But let's do this. So valid values, and here we will do this somehow complicated line of code, and we will put this value equals to x. So we need here to put the position of every A. So what should we do here? So here comes the use of numpy again. So np dot where, and yeah, we will type valid values equals to A. I know it's like for the first time it's like very confusing, but it's actually very powerful because otherwise we will need to make another for loop and another if conditions, and after that assign the value which is equals to A to be assigned to X. So it will be like very long and it will actually be more confusing. So this here will um find every A in the array, or like every square in the array. So for example, if this is 1, it will go to every 1 and change it to X. So as you can see, it's very powerful and makes our life more easier. And we will do the same for B. Change this to B, and at the end we will return true. So yeah, that's it. If if the combination is valid, if we have the combination in the valid values, we will eventually return true because this function will return true or false. And before that, we will remove every A and B to X. So this will be X, this also, this, and so on. Where is the function? Yeah, here. So otherwise, we will return false, and this means that the user uh, chose a wrong combination that's not valid. And that was the is valid function. I know it's too much for the first time, but yeah, it's actually uh, very powerful to use this line here, and it also can be done without it, but we need to make another for loop here and if conditions and so on. So yeah, and tell me if in the comments if you want to see a video about NumPy. It's like very popular and it's very useful. So yeah, tell me if you need something like that. But here we didn't really uh, use much in the library. We just use this method, and yeah, that's it. And we used it here to display the board in 2 dimensions. So yeah, let's move on and make the function for updating the board. And it will also take 2 parameters, A and B. And yeah, I think it's this one it will be much easier than the is valid, because here we will just cover the combination uh, that the user chose with X, and that's it. And actually we will eventually display the board again. We will also use this method again, but this time okay, let me show you. This time we will edit the board uh, array. So board np dot where board is equals to a. Let's change it to x, and the same for b. And at the end, let's display the board. And oops, we will just call the function to it was display game, I think. Yeah. So you can see how powerful making our program in functions. It's much easier. You can call the function more than one time. So yeah, try to use it as much as you can. So yeah, that's it for the display update board, and this will find um, the value that's equal to a in the board and replace it with an x, and the same for b. And yeah, let's take a quick look at the board array. So he will find one if the user combination is 1 and 2, he will go here and change this to x, and the same here. So yeah, now the game winning condition, and this function will check if there is no um, valid combination left, and if that's the case it will return true, and otherwise we will return false. So if we see that there is still a combination that's valid, the game will continue. And let's call the function no squares left. And it will take no parameters. And yeah, so yeah, let's stop for a second and think. It's more like the isValid function, but much simpler. So we will also make a for loop that will go through every valid value. But this time, and the big difference is here, is we are going to check if there is no valid combination, and the way we are going to do this is to see if there is a combination that the values or the squares of this combination is not x. Why? Because if there is an x, this means that this combination is used or is not valid actually. So if there is an x here but not here, this combination is not valid actually. So yeah, we will check if any of the squares of every combination has an x, and if that's the case, if every combination has an x, this means that there is no squares left. But we'll actually do the reverse. So if valid values I and the first square is not equal to x, and valid values I the second square is not equal to x, and if that's the case, let's return false. and otherwise we will return true. And let's explain this part. So here we are checking if, let's go up here. Okay, let's actually take this here to see it clearly or explain it better. So here we are going to check every combination and make sure that there is no x here. So if there is no x in the first square and there is no x in the second square, this means that there is still a valid combination that can be chose. So if that's the case, we return false. We will tell, or the function will tell that there is still squares left. Or okay, let's make it not squares. No rectangle, because we are using the squares for only this. So this all is a rectangle and this is a square. So no rectangles left. So yeah, as I was saying, if that's the case, this means that there is still some rectangles left, and otherwise we will return true. This line will evaluate if we go through every valid combination and we find x in every combination. And if that's the case, we return true. This means that there is no rectangles left and we should end the game. So yeah, this is all the functions that we need. Let's get this back up. And yeah, I think we are ready to go. So yeah, let's now start our game. And if you notice, our game starts with displaying the board. So let's display game. Now I think of it, I think it was better to use board, but yeah. Okay, let's move on. So we displayed the game. Now we need to make players take turns, but if we just type player 1 turn right here and player 2 and so on and add the functions that we will need, it will actually run only one time. So player 1 will have only one turn and the player 2 will only have one turn. So we need to actually make a while loop. And yeah, complete our program here in the while loop. The reason I haven't put this function or the call of display game inside the while true because it will actually uh, not work as intended, because here we will display the game. It will make a mess, and actually we also will call the function in the update board, so we don't need to worry about this part. And at the end, I will actually show you what happens if we put the the call here inside the while loop. So yeah, the first thing is um, the player's one turn. So player one turn, and what else? So it's player's one turn. He will be asked for two squares. We will check if it's valid, and if it's valid, we will update the board. And since we have display game here, it will display the board again. So yeah, so everything pretty much is inside the player one turn. The checking if it's valid, updating the board. So what do we need to do here? The only thing left, or the only function that's not used, which is this function here. So if it's player's one turn, we need to check after his turn if there is rectangles left. So let's make an if condition, and if no rectangles left, and if that's the case, that means that player 2 has no move to make, so player 1 wins. So let's print player 1 wins, and let's break the while loop right after this because the game will be over. Okay, if not, if there is still rectangles left, now player 2 can play and take a turn. So now player 2 makes a turn. So we will also check if there is no rectangles left. And if that's the case, that means that player 1 has nothing to do and player 2 wins. And we will also break right after this. So the first iteration will end here. So if the rectangles, if there is no rectangles left, we will break and the player 2 wins. But if there is some rectangles left, the iteration will begin. A new iteration will begin, and player 1 will take a turn, and so on. So let's actually test our game and see if it's working. Okay, let's try 1 and 2. That's a valid value, so it's covered with an X, and it's player's 2 turn. Let's see if we put invalid combination 11 and 16. Okay, it tells me choose a valid rectangle. So now let's choose a valid rectangle. Let's 4 and 8. It's all. Oh, we have a problem here. 4 and 8 should be a valid rectangle. So let's see where we messed up. But before that, let's test other values. So 3 and 7. Okay, I think when it's vertical, the problem appears. Let's try 5 and 6. It's also not working for 5 and 6. 9 and 10. Okay, it's not working at all. So where is the problem? It will probably be in the isValid function or not. No, it's choose a valid rectangle. Yeah, it's in the valid. It's in the isValid function. And yeah, and I think the problem is here. The return false is not indented right, because if it's like that as before, this means if or after the first iteration we will return false. So we need to return false after the whole for loop is over. So let's test again. 1 and 2. Yeah, and the reason 1 and 2 worked because it's the first valid value we have. So this will be the return true will be evaluated from the first iteration. But when we try something like 3 and 4, so the if condition will first look at the first combination, which is 1 and 2, and it will see that okay, what have I done here? Okay, yeah, as I was saying, it will see that 1 and 2 is not uh, a valid value, so it should uh, look at the next combination, but since we added this here, it will return false immediately. So we need to uh, adjust this indentation, and let's try again. 1 and 2 will work. Let's try 3 and 4, and yeah, it's now working. And let's test again. If we put invalid value, okay, it will tell me to choose a valid rectangle. Okay, now let's end the game. So 6 and 7, it's working. 11 and 12, it's working. And the last combination, I think, yeah, it's 9, 13, or 5 and 9. So let's see, 5 and 9. And since the player 2 is the last player who took a turn, that means that he wins. So player 2 wins. So yeah, that's awesome. And I think we went through every possible scenario, I think. So yeah, but yeah, I remembered. So I said we will see what will happen if we put display game inside the while loop. What is happening? So yeah, let's see. Let's run our program. So yeah, in the first iteration, everything is good. So 1 and 2. And let's see, 3 and 4. And I think now the program will appear because the iteration will begin again. So yeah, as you can see, we have two boards now. So it's this is how it will mess up our game. So let's return it back, and yeah. So yeah, that's it. And yeah, by the way, uh, a challenge for you, if you want, is to make another function or the same function but make it simpler. So yeah, that's a challenge for you, or use another way other than using in NumPy dot where. And yeah, good luck with that. And I think, yeah, this is it for today. And yeah, I'm thinking of making the second project in this series is to be another game, X and O. It will be much simpler, I think. So yeah, tell me down in the comments if you think it will be a good practice. And yeah, so that's the end of today's video. Thank you for watching. Don't forget to hit the like button and subscribe to the channel, and see you next time.